Hey, what's up, guys? It's Bob from Code Bros back at it with another top interview question, medium set. This time it's number 4 in the raising strings, a longest substring without repeating characters. So, given a string as, find the longest substring without repeating characters. So, over here it's ABC, and they return the length of it, so it's 3. But you can also return BCA or CAB, as they're also substrings without repeating characters of length 3. We can also use those to get the maximum length. Over here is just any one of these B's. Over here, see P, W, then WKE is the longest, and then W. So let me explain to you what the main idea about this problem is. So we have the string, and what we want to have is start of window and end of window. And this is basically a way to visualize the problem. So you both have a start of window and end of window. And think about it, it's called the sliding window problem because you're just sliding this window open and close. So what are those two conditions? When we're opening a window, it's when we've seen a unique character that we haven't seen in our previous substring. So we see A, B, C, you're opening the window. Then you want to, because you're moving the end of window forward. And you want to update the max length, of course. But then when you see A again, you can't really open the window anymore until you remove that last A. So you get where that last A is and jump forward the start of window. So now you have B, C as your substring, and then you can add A. And you take the max length and you just keep on going like that. So let's call the start of window SOW, end of window EOW as abbreviations. And of course, we need a max length. And we need to store all the characters that we've seen so far so that we can jump the start of window forward and check if we've seen the character again. So what's this data structure that's really good for search lookups and can store like a pairs? That would be a hash map where we store a character and an integer, and we'll call it scene values. So let's just have a little run through the problem. Scene, start of window, end of window, and max length. So start of window and end of window in the actual problem, they're going to be indices in this array. We're going to convert this to an array. Well, strings are technically char arrays, but same difference. But for this, we're going to show the values so it's easier to understand. So scene is initially empty. Start of window is initially at the first character A. End of window is also at the first character. Max length is also 0. So the first character that we actually see is A. We add that to the array as it's a unique value and we haven't seen that key before. And we update the max length to 1. Then we see B. B is also a unique character, not in the key set of our hash map. So we add in, update this to 2. Then next character C, same thing. Update max length. Then next character we see is A. So we've already seen A and it's in our hash map. So how do we make sure that this string is now a unique substring? So start of the word is at A, end of the word is at C. We want to take the indices that the next end of word is at, which is A, and then increase it by 1. So start of window is equal to 0 plus 1, and that value is B. And you'll update A as now the new indices that we've just added, which is 0, 0, 1, 2, 3. So initially, I'll just explain to you what we just did. We just moved the start of window to the last element that is the duplicate, and we added 1 so that we are ignoring everything before that. And now we have the string BCA right here. Then we see B, and we can't add it, so we move this to the next element, which is C, add B. Now B is now at the second B, which is at index 4. So this is the word CAB. And we just go through the string like that, updating it as we go. And that's the main idea of the problem, where it's a sliding window. And we're using a hash map because it has a good search time. So let me quickly explain the time complexity. So the time complexity, if you think about it, we're going through all n characters every time. So n is equal to the number of characters. You define it like that. And we're always going through the number of characters, which is O(n). Base would be, worst case scenario, our string only has unique characters like A, B, C, D, E, F, nothing, no duplicates, or whatever, duplicates or anything like that, multiple characters that are the same. So that means we'd have to store every single character and their indices, which is n characters, so O of n, which is O of 2n, because you gotta store the indices as well. But yeah, O of n, simplifies O of n. And now that we have that done, let's try and do the problem. Oh, I already did it before, but I'll type it out, my thought process for you guys. So we have a hash map of characters and integers, which are our theme values. Oh, got a new keyword. Okay, so now we have start of word equal to 0, end of word equal to 0, and our max length also equal to 0. And let's convert the string to a char array, just make it easy to work with. Okay, cool. And let's store the length as well. Length, cr, and we want to do a while loop while the end of the word is less than the length of our string. So I'd iterate through every single character. We have two cases. So we'll start with the duplicate case first. So for a duplicate to exist, first off, it has to be in the hash set. That's the first condition. Or hash map scene.contains key. So the current letter we're looking at. And the second condition is that it has to be after the start of the word, after or equal to the start of the word, because we could jump the start of the word forward and have some characters that are no longer in the substring that we're looking at, and they'd still be in the hash map. So we want the scene.get, make this, and scene.get character at the end of the word to be greater than or equal to the start of the word. All right, that's great. And this is when we see a duplicate. So what do we do when we see a duplicate? We want to move the start of the window forward. And how do we want to move that forward? So by the first occurrence of that value, +1, which is a new value. Then we want to add the character that we're currently looking at into the string. So scene.put character at end of word. And now this is the only occurrence of it. And the last thing we want to do is increment the end of the word to a new value, but we do that yeah, let's just add it here anyways. And our else case is when we see a unique character. So what do we want to do? We want to first update the hash map. Then we want to update the max value. End of the word minus start of the word +1. You might think why I'm doing +1. It's because it's the end of the word and start of the word are inclusive. So if you see like 0, 0, if end of the word is equal to the start of the word, 0, 0, and that's one character, right? But the end of the word minus the start of the word is 0, so we have to add 1 there. And we increment the end of the word. And as you can see, we can simplify this further by just like popping these two out because they're the same in both cases. And remove these two. Move this. All right, so now let's run the code. Compilation error. Oh yeah, forgot the return statement. All right, run code. All right, so our initial test case passed. Let's do a more comprehensive test. All right, great. That was accepted. Thanks for watching. Code's always in the GitHub link in the bio or the description. If you guys have any suggestions for videos or what I could do to improve these videos, please let me know. Also, if you're a company and you want to hire an intern, I'm available. And that's all. So thanks for watching.